So this is a LXD team live stream, a bit of different from the previous ones because we actually have everyone up. In this one, we're going to be going through the LXD roadmap, kind of what to expect over the next 6 months. Hopefully, we'll be doing one of those every development cycle, so expect one of those pretty much every 6 months. First, I'm going to go through who's on the LXD team. So let's do alphabetical order-ish. With Christian as our kernel developer on the team. He's doing a bunch of work around namespaces, some amount of file system stuff in the kernel. PDFDs is his main baby these days. I also worked on binder.fs and is the LXC and LXCFS maintainer on the team. Then we've got Free, who is the libraf, libdqlite, godqlite maintainer, and also contributed pretty much all of LXD clustering into LXD and is maintaining all of that stuff. Then we've got Thomas, who's working on distro builder, is the distro builder maintainer, does all of the image building that we do for both container and virtual machine images in LXD. He's also been pulling his hair out recently with Windows support and building Windows images. And been doing some work on the LXD agents that we run inside virtual machines and our virtual machine story kind of in general. Then we've got Tom, not to be confused with Thomas. We've got two of those. So, that's how we differentiate them. Who's mostly working on networking these days, but also storage, clustering, and virtual machine for LXD. But like, all of the newest virtual network type features in LXD have come from him recently. And then myself, I'm the engineering manager for the team, also the project leader for LXC, LXCFS, and LXD. And these days, I mostly try to make things run smooth. I try not to really bite any big feature or anything by myself, but just help and design everything else. Now, on kind of how the roadmap works here on the team. So we work on a 6-month cycle. That mostly comes from us working for Canonical and Ubuntu being Canonical's main product, which releases every 6 months. So the planning within the company is usually aligned to that. So our planning is also aligned to it. That means we've got one cycle which is from April to October and one from October to April. LXD LTS releases are also synced with Ubuntu LTSs. So that means releasing every 2 years in April an LTS that we then support for about 5 years. All the other releases that we do in LXD tend to be monthly releases. We find that's a pretty good pace to still be able to ship stuff to users pretty quickly. Makes it easier to also deal with any potential regression issue, etc. In between those monthly releases, we do quite actively cherry pick bug fixes and push those out to users as well, so they don't need to wait an entire month. And then all the bug fixes that we have in those feature releases, we backport onto the LTS, which normally do not get new features. We only get bug fixes or like feature gaps we need to fill on those releases. All right, let's go to the actual meat of this and look at the different features we're looking at getting over the next 6 months. So the main area of development for LXD lately has been virtual machines. The main reason for that is that we're kind of playing catch up. We've got a lot of features that we support in containers that we just don't support right now in virtual machines, and we want to get that feature gap between the two to be as close as possible, or as small as possible. So we've been trying to fill that in recently. It means mostly, device pass-through and device support has been a big thing for virtual machines for us for the past year or so now. This cycle, we're adding support for USB, raw PCI device, and different type of GPU pass-through. So like on the USB side, that's work that Thomas already did, and that's been landed in 4.7. That currently lets you pass any local USB device to your LXD server into virtual machines. But it also supports, I believe I've configured 3 or 4 ports that are redirected over SPICE. So if you use the LXD console API from a remote system, you can still forward USB devices as well. I think that work went pretty smoothly. No big surprises there, other than IBM Z mainframes S390X do not support USB, so we ended up not having some issues with the LXD config until we fixed that to remove any trace of USB on those systems. The second bit is arbitrary PCI pass-through. Right now, we support passing through PCI network cards and PCI GPUs. And for those, we track down the right device. We set up things like SIOV, and then we pass the proper PCI device into the virtual machine. There's a general request to just support any PCI device. For those that know what they're doing, they should be able to just tell us, hey, this particular device, I'd like to move it into a VM. And it's pretty straightforward to support, so we're going to be doing this cycle. And the last one is around GPU pass-throughs. Right now, we support passing through an entire GPU, but a number of GPUs, including some of Intel's embedded GPUs, can support either MDEV or SIOV, which lets you slice your GPU and then pass a slice in. Just to clarify there, it's primarily for compute, encoding, and decoding. You can technically do a rendering against it too, but you can't get you won't get like a GPU output. You can't say, I want the VGA port on my laptop to be tied to a VM, for example. That's not something that GPUs commonly support, but will still be quite useful. The next point is we actually see it in both virtual machines and containers. That came also from work that Thomas did. We now have support for VTPM devices. That's effectively like a separate process that we run with the alongside the virtual machine or the container, and that provides what looks like a normal TPM inside of the instance. The primary use case for that would be for things like encrypted storage inside a virtual machine. You could use that for those kind of applications. You could use the TPM to like seal an HSM if you need like certificate storage that's potentially slightly safer. And you could use that for some kind of remote attestation and like measurement of the boot of the VM and how it works. Another piece that we're now starting to look at are stateful snapshot and stateful stop. So we know that people would really like to get live migration with LXD virtual machines, and that's definitely our goal, but that takes a little while. There's a lot of things to consider around, like simple things like you need the hardware on both sides to match, or you need the VM to be voluntarily restricted to the smallest set of hardware features you have across the machines you want to migrate to. That's a bit tricky. We'll need to do something about it. We might end up having to like making a flag that you need to put on the VM saying, hey, I want this one to be something I can live migrate. And when that happens, we will actually like dumb down the definition effectively of the VM to a more standard CPU type that's more likely to be compatible with your other systems. But for now, what we're doing is just focusing on single system, which avoids those kind of issues, and making it possible to do a stateful stop where you effectively tell LXD, stop this virtual machine, but instead of shutting it down, serialize its state down to disk, and on next startup, restore the state. So that's effectively hibernation, like in the real world or even in some other VM products. And because of how LXD works, that we can also include that kind of state as part of a snapshot, which then lets you restore a snapshot, including runtime state. We've got that for containers. We want to have it for virtual machines too, and we think that should just fit nicely with the other feature. Then we've got VirtaUFS support. I'm not sure, Thomas, did we ever do any kind of testing on the speed for VirtaUFS?
No.
Okay. Yeah, that's something which they kind of need to look at. But VirtaUFS is being marketed definitely as being significantly faster than 9P for shared file systems between containers, between hosts and virtual machines. So it's effectively using some kind of variation of fuse and like shared memory directly between hosts and the virtual machine. And even on the host, it's supposed to be able to then use things like zero copy to make it very, very fast to access data and not needlessly duplicate things in memory. We've added that recently in LXD. It's gonna I think it's already in the 4.7 snap because we've backported it, but otherwise it will be part of the LXD 4.8 release. And it's effectively transparent. The LXD will announce every single share as both 9p and VirtualUFS, and the agent in the VM will attempt VirtualUFS first and fall back to 9p. So you'd always get the best performance. That also means we're effectively fixing our CentOS 8 story with this, because on CentOS 8, for some reason, they decided to remove the 9p kernel module at some point after CentOS 8 was released. So it's effectively a regression, which prevented us from running the agent inside those virtual machines. That's now been fixed because they do ship VirtualUFS, and so VirtualUFS is now being used on CentOS 8, and things work again. If you've got existing CentOS 8 VMs that stopped working, you will need to manually mount the VirtualUFS config share and then run an install script in there to refresh your systemd units. Then on next startup, it will work here again. And for anyone who's spawning new CentOS 8 instance, you get the new units that support both 9p and VirtualUFS, so things should just work. Then we've got a bunch of hot plug stuff. Well, currently we're mostly caring about hot plug of network devices. We did earlier, like a bit earlier the cycle, we added also the ability to hot remove memory effectively by inflating a balloon inside the VM. That's work that Tom did, which lets you like put memory pressure inside the VM to release memory back to the host. That's like one example of us being able to actually modify limits and devices directly on a running virtual machine. The next step is we want to add hot plug of network devices so that you can, we've got like a preset number of slots on the PCI bus that we can hot plug network devices into. That would probably allow adding, I think we're probably going to go for like four additional network interfaces that way. And we will probably end up using the same mechanism to also eventually do USB device being added live and some other bits. Not sure what else we should support for hot plug. Like hot plugging memory is definitely interesting, but you need to really change the way you manage memory in virtual machines for it to work. Like you need to go for individual DIMMs and have like a number of DIMM slots that are not populated yet and then populate those. That can work, but it gets pretty tricky. And hot remove of those DIMMs is obviously even trickier. But for those, you could use the balloon. The CPU hot plug, hot remove is also quite interesting and in theory similarly possible, especially with the agent inside to help us. I guess GPUs is something we could probably do the same way we do networks because it's also just PCI devices. We just like plug and unplug. How the system will behave with unplugging is always a bit up in the air. We don't really know. The agent running in the VM can definitely try and make things clean by unloading driver, detaching the device as much as possible so that it's ready to be removed. But yeah, hot remove might be trickier with VMs than it is with containers. And the last piece we've got for virtual machines is around improving performance for networking. So right now we do support things like SRIOV so that you can pass a VF of a very fast network card directly into a virtual machine. But that doesn't give you any ability to attach that VF to a virtual network. As it turns out, there's hardware out there that does support exactly that. It supports effectively offloading an OpenV switch or even switch onto the card, giving you a VF that's directly tied to a bridge effectively. That's quite interesting to us. We'll probably end up supporting that because that's going to give kind of the best of both worlds of being able to use virtual networking while getting like PCI type performance, like raw VF type performance. And there's some more improvements around that field that we're also looking at supporting in the future. Like even newer cards support a feature called VDPA that lets you directly keep a VirtualNet network device inside the VM, but then have the hardware handle the send and receive buffers directly, which should be the best of both worlds because we can then easily live migrate those instances. The guest doesn't know whether it's running on a fully virtual network card or whether it's whether it's managed by physical card. So that would be quite ideal, and we're looking into those options. Okay, next up is on containers. We've got less going on containers than maybe we did in the past, mostly because we already support a lot of stuff, and as I said, we're mostly playing catch up on the VM side. So again, we're doing VTPM support. That's been done already. It's effectively the same stuff as the virtual machine. It's just instead of providing a socket that QEMU can consume, we're providing character devices that can be used by the container. So behavior is quite similar. Checkpoint restore. I don't know if Christian has any comments on that, but like our story has not been amazing in the past. Like we did have checkpoint restore working quite well a few years ago, but then new features like APAMO namespacing, newer features in systemd have really significantly reduced the amount of cases where this can work.
I think there is one fundamental difference. First of all, for a long time, checkpoint restore wasn't one of the most wanted features for users, I think, by users. And then recently it gained more traction again, which is great, with work that we've helped to enable in the kernel, where it's now possible to use checkpoint restore in unprivileged scenarios, because that has slowly become a use case. And there's a fundamental difference between how we would need to use checkpoint restore and how, for example, application containers or application container runtimes would use checkpoint restore. In an application container context where you usually have a single or two or a couple of well-known processes running inside of the container, and you want to checkpoint and restore them, this is a way easier case than, for example, having a system container where a full init system such as systemd is running that makes use of all the new kernel features. Because checkpoint restore is implemented in user space, every time the kernel gains a new feature for sockets or whatever, the user space program makes use of, checkpoint needs to be checkpoint restore, and the user space side of it needs to be adapted to handle this new kernel feature. Otherwise, checkpoint restore will, in most cases, fail. And given that systemd, for example, is a fast-moving project, making use of new features, and then you have an old checkpoint restore version, it's way more likely to fail. So it might be able to checkpoint restore an Alpine container, because it's really just it uses a limited set of features in the kernel. But if you use a full init system, a standard Linux distribution run by systemd today, checkpoint restore is very likely to fail. But we at least want to get it in a shape or in a state where you can, if your workload is well known, you can confidently use checkpoint restore.
Right. Yeah. Exactly. Like in the past, our previous attempt at doing checkpoint restore, kind of in the beginning of LXD, was to try and get 90% of systems to checkpoint restore cleanly. These days, and like with the experience we've had over the years, we realized that this is just not going to happen. But there is definitely a market for users that very tightly control their workloads, very tightly control what runs in their containers, and that do want to use live migration or stateful snapshots. And for those people, we can definitely make things work. Currently, the main two gaps on the LXD side here is the APAMO namespacing, which is not currently supported by Creo, and the fact that we pass in physical network devices for every single network device inside containers. So LXC, which drives Creo, doesn't actually know how to reattach those network devices, and therefore restore fails. Some of that is effectively, like, it shouldn't be a ton of work. The APAMO namespace might be a bit of work. The other side is mostly changing LXC so that LXD can tell it what to do. Like, LXD can definitely recreate those network devices, no problem, and pass them in. But like we need some kind of cooperation to say, like, hey, yes, those network devices on the host are what should be those network devices inside the namespace. Right. And then when LXD and Creo work together to restore the container, they can make sure those devices are moved and renamed appropriately inside the container, and then things move on. That shouldn't be particularly difficult. I believe Creo actually already supports doing that, but we need to make sure the plumbing works all the way so that LXD can pass that knowledge through and LXD can do the right thing.
Yep.
The last thing we've got around containers, something I've actually been working on yesterday, is daily testing for cgroup v1, cgroup v2, and fixing anything that's broken. So that applies to like all of our resource limits and the behavior inside the container.
Right, so we should stress that we did have tests for cgroup v1 and cgroup v2, both for LXD and LXD. What Stefan specifically is referring to here is tests for a feature of LXDFS that virtualizes swap values and proc info and proc swap based on the C group of the container, and that is abhorrent and terrible to get right. And he fixed a bunch of that stuff and also added some tests. We basically made an executive decision where we said, this is how we're going to virtualize swap. This is to the best of our knowledge how we can make it usable for users.
Yeah, so I mean, there's more than that. Like, yes, so in the past we definitely didn't. So we had some amount of testing on like CFS itself. We have some amount of testing on like config validation and scheduling behavior in both LXD and LXD. The LXD test suite doesn't actually test any of the limits because we don't know what system we're going to be running on. So we don't know what kind of limits we can realistically apply and expect to work. So
Yes.
far, a lot of those tests I've done manually with every single LXD release. So we're changing that. Starting yesterday, we've got a test that actually validates memory limits, CPU, including like CPU number, CPU pinning, CPU shares, and scheduler quotas. And we also validate things like network limits. So I run iperf from a container going to the host, and we measure the bandwidth both up and down without any limit, which in our test environment is about 15 gigabits per second. And then we try again putting a fixed limit like 20 megabits down, 50 up, right. And we measure that up and down are no higher than those values after the limit's been applied. So now we've got that in place. I'm also checking things like network priorities, so that making sure that those are also applied. I did write a test for block IO priorities as well. The problem is that nobody is using CFQ these days because everything moved to SCSI multi-queue with either the standard multi-queue driver or with the non-scheduler, in which cases we don't have any control on that whatsoever. So the block IO priorities don't really work for 99% of systems these days. The block IO throughput limits are either in bytes or in IOPS. Those still work, and I do validate those. What else do we have in there? So yeah, we're effectively, like, I went through the entire list of all the limits we have and make sure that we've got a test for every single one of them in that test suite. That's not running.
Differentiated between cgroup v1 and cgroup v2?
So currently we only do cgroup v1. The two tests that are being run is cgroup v1 and cgroup v1 with swap accounting. So we make sure that the memory behavior works properly. I actually tried the out of memory kill as well in the memory case. So actually I create tempfs and then write more than I've got memory in there. And I make sure that if we're in hard enforcement mode, we do get an out of memory kill and that fails. That if we're in soft enforcement mode, that this succeeds. But this particular test, you could not run it without swap accounting. Because if you don't have swap accounting, you're allowed to consume as much swap as there is, which then makes your memory limit somewhat pointless, because so long as you've got swap enabled on the system, you can still use more and more memory. So I've got that sorted. The next step is indeed to take the test suite and run it on cgroup v2, and for every one of those points be like, okay, what are we doing? Are we doing the right thing? Is cgroup v2 capable of supporting it? So I kind of need to.
Has the behavior completely changed in the meantime?
Yeah, exactly. So I think that's gonna be a spreadsheet on my side of like every single one of our limits. And like, are we doing the right thing at kernel level, LXC, LXCFS, LXD? And for each of them going through that and being like, okay, this clearly doesn't work. Does it not work because they've not implemented it yet in the kernel, which is often the case? Or is it because the concept is different and we need to like decide what that means, like what that limit actually means now on sync group 2 at the LXD level? or is it not working because we've got some issue in LXC? I mean, it's effectively reading the file system, so it's kind of hard for it to mess up.
And it can be quite significant. For example, if you're just one specific example is the memory C group in the C group V1 and C group V2 implementation. If you want to know the memory limit in the C group V1 C group, you can just read memory limit in bytes for your C group that you're actually interested in. Because it's always to be guaranteed to contain a value. But the problem is for C group V2, if you read your current C group's memory limit, there might not be any limit set, which means there can still be a limit set higher up in one of the ancestor C groups. So what you need to do is you need to walk up to the root C group until you encounter a limit.
Yep.
Or none at all, at which point you know that memory is unlimited. But this is really a problem, especially when you consider that you could be in a C group namespace where you're not even able to walk up to the root of your C group tree. Well, anyway,
so there's a bunch of interesting cases of C group V2. I also suspect we've got a lot of gaps in LXCFS in that regard, like setting C group V2 limits and then expecting LXCFS to do the right thing.
LXCFS handles at least for the memory C group and so on, all of these quirks it already handles. And for a bunch of those where we are aware of these, not quirks, but of this altered behavior, LXCFS has been adapted, but we should definitely make sure that it handles all of the corner cases correctly. And I still think that it would be worth fixing some of the the altered behavior in C group V2. For example, the C group namespace issue that I just mentioned. I think this is something that we should at least look into fixing.
Actually, just remembered, I'm going to make a quick note here that my test is actually slightly incomplete in that I need to test freezer as well.
Freezer is freezer
should
V2
be a thing these days, I think, on C group.
Freezer V2 is already implemented and supported in LXC. So LXC will already correctly handle freezing your container. And the nice thing is that with Freezer V2, with Freezer 1, you basically wrote freeze. I think freeze into a file, and then
freeze all caps into a state file.
And then you needed to keep reading the file until you actually read the string frozen or something in there.
Yep.
And that behavior is different with C group V2, which is nicer, which is C group. First of all,
actually atomic now.
Yes, exactly. And C group, the freezer is not a separate C group; it's a file in every non-root C group. Because obviously you don't want to freeze the host. So, and this file is pollable. So you get notified when you're frozen. And LXD already handles this.
Yeah, like we're going to have to, because like on the LXD side, this is not a limit. I mean, it's always been a bit of a weird one because it is not a resource limit. It's kind of just a convenience function effectively. And so for us, the way it's used is when you do like a snapshot on a directory backend or a copy on a directory backend, we do a temporary freeze to guarantee that IOs or guarantee that files are not changing underneath us. And we also have a LXC pause command that can be used to temporarily freeze an entire container. So I just need to make sure we test that as well. All right. Then on the networking side, so that's one of the pretty busy things on our side. Not sure if Tom wants to comment, but we started to work on the design for security groups and firewalling. And go ahead.
Yeah. So basically, we're going to be introducing the concept of network security groups and port groups for virtual networks, and then allowing you to add rules to network security groups to put in place a policy of what traffic you want to allow. And I think based on our discussions yesterday, we're sort of going to default drop if your traffic doesn't match any of the rules in that group. And then basically those rule sets and those security groups will be assigned to ports, so you'll be able to apply a network policy to a network interface on a particular VM or container and have the virtual network enforce that policy for you.
Yeah, and we're looking at, because you should be able to apply multiple ones of those per port or like per instance. It should also let you do policies like those 3 VMs are, web servers. Those 2 VMs are my database servers. And then in the policy of the web server, you can say that, okay, I allow, or actually the other way around, in the policies of the database servers, you can put a rule saying that you allow traffic coming from those that are in the web server security group. Yeah. So effectively, port group, the user will see that as being a bunch of security groups, but we apply that as port groups internally. So that makes things a bit more flexible than having to figure out all the IPs and allow everything in hard-coded way. The other thing we've done, so that what has already been done, is allow for external subnets to be routed to LXD instances. We mostly needed that for the overlay oven feature that we've implemented. That lets you run. So you've got instances, they get private allocations from their bridge. You might still want to give them a public IP. You've got those public IPs being routed to the uplink network that the overlay network uses. And we can then assign some of those public IPs to a particular project. So effectively delegate a set of external addresses to a specific project. And then within the project, whoever has access to that project can then use those addresses in one of 2 ways. One is they directly assign one to an instance. And in that case, we will route that address directly to the instance. The other thing they could do if they've got large enough chunk of address space is literally run an entire bridge off of external addresses. That's mostly done for IPv6, but could also be in theory done for IPv4. And that's how you can get external addresses onto a otherwise completely isolated overlay network in LXD. The last bit we've got, we've not actually looked into doing it yet, but it's refactoring of how we do low-level network operations. Right now, we've got a lot of places where we will call IP route effectively. So call the IP command or other commands coming from it, like VLAN, and just let that command do the right thing with the kernel by having it interact with netlink. That's a lot of forking. That's a lot of potential issues because we're not sure that all Linux distributions have the same version of IP route and exactly how it behaves. We've been quite lucky so far, but our luck might run out eventually.
So, example that where IP out of the box is different.
Yep. So we'd like to switch those to first extract all of those from the LXD code base, move them all to a nicely isolated package. Once we've got clean functions in that package, we can one by one port them over to doing straight netlink. So that's the plan there. Then we've got a bunch of stuff in clustering. The 2 first items there are primarily for security. So currently, the way you join a LXD node into a cluster is by using the trust password. Trust password gets you full admin on the entire system or on the entire LXD cluster or LXD host. And it's not restricted to just clusters. So someone who knows that password can also just add themselves as a regular client and do whatever they want. Instead, we want to move to a mechanism where we can create pre-join a machine effectively. So you do LXD cluster add to say we're going to be adding a new machine, give it its name. As a result, you're going to get both a token and a small blob of data. Then when you do the join, you can use that token instead of the trust password to join. And that will join you specifically as the name that's already been predefined in the cluster. And the other part that's kind of interesting is that blob we're going to give you, which is effectively like a base 64 encoded string, is something you can pass directly at the beginning of LXD init on another node. And that will include the name of the node, the name of the machine that you're joining, its token to join, as well as the addresses that the cluster currently listens on. So that lets you do that first, that initial join very quickly, and will just prompt a few questions if needed for storage and networking, then you're done. So we're quite looking forward to that. On the other part of security. Right now, the way the cluster nodes communicate between them is by using the cluster certificate. And so if we see the cluster certificate as the client certificate being used, we're like, okay, fine, it's an intra-cluster request effectively. That works fine. The main issue there being that if we need to kick out a cluster node, then it still retains access to the cluster, which is not necessarily ideal. In the case where like a node gets compromised, right now you need to regenerate this cluster certificate and replace it everywhere. So one thing, like the first step we want to take to fix that is by having the cluster nodes use their own local certificates as the client certificate, and have like a separate category in the trust store that we've got in LXD to record that that particular client certificate is a cluster node. It's this particular cluster node. It's fine. And then when we remove the node, that entry will get revoked. So the server is no longer allowed to access the database or access any of the cluster. There still remains the issue that we will still have a cluster certificate because we want to provide the same certificate to clients on every one of the, like regardless of where they connect to. So if your node actually gets compromised, you will need to still regenerate that particular certificate because you don't want your compromised nodes to be able to impersonate the cluster. But we also have plans down the line there to add an API that will let you either upload a new certificate, thinking like, Let's Encrypt, for example, like a valid TLS cert, or just ask LXD to regenerate a new one. Obviously, when that happens, so if you upload the Let's Encrypt or a valid certificate, then it's fine. Your clients will just use their local CA validation to validate it, and it will be perfectly okay. If it's a self-signed certificate like LXD normally generates, then as soon as you change it, none of your clients can talk to the cluster anymore because the fingerprint no longer matches, and they'll have to remove and re-add the remote. So that part is always a bit bumpy, but you should only really need to do that if you do have a node that got compromised. Okay, health and warnings. That's something also quite keen on adding. Right now, LXD will log a number of warnings both on startup and as you use the system when something looks wrong and that you should take a look at. But there's no good way to report that to the user or have a monitoring system look at that other than passing logs. So we're looking at changing that. That will look like a cluster ward API that we can query that will tell you, hey, those instances of like some bad configuration, you probably should take a look at those. Or also this node, like it's missing some kernel features that you should really enable. Like you might want to go and update your kernel or change your config a bit on that particular system so that you do get all the nice kernel security features that you should be getting. So that kind of stuff. And because that's going to be an API endpoint, it's going to be pretty easy for someone to use to integrate that with their existing monitoring infrastructure and record how many warnings they're getting, what kind of level of warnings or category of warnings they're getting, and then alert based on that in a reasonable way. So that should really help with operating clusters. Then the next step is project resource usage. That's a bit of a gap we've got right now. So in projects as they stand, you can limit resources. You can limit the number of instances you get, the number of virtual machines, containers, amount of disk space being used, number of networks, like a whole bunch of things you can restrict right now. But there is no way for you to know how much of it you've used. So you effectively use those resources until LXD says no, at which point you know that you've hit your limit. You can technically go look through all of your instances and networks and storage and manually count things. It's definitely possible, but it's really not easy. So we want to expose that as like an API on the project so that you can easily figure out where you stand in your resource consumption. And whether you need to ask for your administrator to increase your limit, or maybe you need to take a look at what's consuming so much resources and free some of that. And the last one is effectively a bug fix, but it's a pretty complicated bug fix, so it's on our roadmap. It's improving the way we do cluster image management. So right now inside a cluster, you've got the image store. The image store appears to be kind of shared on the entire thing, but in practice, on we really need to kind of track where we put images. It doesn't make sense for us to have them everywhere. So when you manually generate an image with publish, or you manually copy an image into your cluster or import an image into the cluster, we will, in those cases, record, we're going to replicate the image. We'll replicate it to at least 3 nodes. It's configurable. You can use less or more as you want. The problem is that right now, our logic tends to always pick the same 3 nodes, which is not ideal. So we need to fix that. And then the other issue we've got is with refreshes. So because of the way clusters tend to update themselves, all the clusters members will tend to have been started at the same time. That also means that the refresh timer, which kicks in by default every 6 hours, will run pretty much at the same time on all of them. And that particular refresh logic then iterates through every one of the images in the image store, not just your local ones, and tries to refresh them. The issue there being that all of them are doing it at the same time. They're all processing the exact same images at the same time. They're all reloading the exact same thing. And then they hit race conditions when they try to update the database. So the current plan on fixing that is to effectively make any one image fingerprint should only be handled by one cluster member. Whether it stores it or not locally, it doesn't really matter. But only one cluster member should look for updates and handle refreshes. And when they do, they need to, look if there's something more recent, look what projects are affected, refresh, update those projects. If nothing references the old image, then you can delete the old image, otherwise you don't. So it's our normal refresh logic, but it needs to be done in a way that it's not completely racy like it is sometimes right now. I think there's actually one last piece on the image management, which is if you are on a cluster that can use CephFS, with CephFS, you can technically expose the exact same image storage to every one of the cluster members. And we want to support and optimize for that so that those users can just create one CephFS volume, have it mounted on every one of their cluster members. And at that point, it's considered that every image is by default replicated. There's no need to replicate it to multiple nodes. So yeah, it should improve stability and performance, and also save a bunch of space. Okay. Now for the storage side, that should be a pretty quick one. There are just a couple of things we want to improve there. LXD, like right now we've got that LXD import command that lets you recover individual instances where you're lacking the database record, and we recreate the database record for both the storage pools and for the instance itself. We've got more things that we need to recover these days. We've got custom storage volumes that we should also be able to recover the same way. And in general, the fact that right now you need to manually mount everything in the right spot before you can run LXD import has been quite painful to users. So instead, we're looking at doing a new LXD recover command that lets you define what your storage pools are supposed to be. Once those look good to you, then LXD can treat them as storage pools, look like that pull from the storage pool what's on there, mount everything, and then import, which should be significantly faster and easier to use for our users. So quite looking forward to that. And also right now we report usage of storage volumes as part of the instance they're attached to, not on their own. We just want to add an API there so that you can do LXD storage volume list and have a column that shows you the usage for those. It's not going to be easy to pull in all cases. It's probably going to be like an optional column type thing, but that will definitely help to figure out, within my storage pool, where's my data going. On kind of the core of LXD, so not really in any of the other buckets, just before we go into some of the low-level stuff with Christian, we've got a few more tweaks. We want to make it possible to restrict a single client certificate. So when you're using TLS authentication, restrict that to a specific, to a set of projects, and within those projects only get an operator role. So what that means is you'd be able to go and edit the trust store, say this client only gets to see project foo and bar, and then if you apply limits and restrictions to those projects, because the user will not have full access to that particular project, they will not be able to escape those limits by bumping them themselves or removing restrictions, for example. They'll be able to create instances, networks, storage, whatever inside the project just fine, but they will be tied and by the restrictions we applied on the project. The other thing is generating REST API documentation automatically. Right now, it's a single markdown document that we reasonably often forget to update when we add new stuff. We usually think of updating it when we're adding new API endpoints. We don't always think to update it when we add new entries on different API objects. So to simplify that, we're looking at doing auto-generated documentation. There are a couple of something that kind of looks like a standard around that, and so we should be able to just annotate functions in the code, both in our existing API package and inside the LXD API handlers themselves, so that the documentation can be generated from that instead of being something we need to manually update every time. So it's going to force us to write better commands, but the result should be a always up-to-date API documentation. And lastly, we need to switch to core 20 for the snap that we maintain. Right now, it's on core 18, which means Ubuntu 18.04. 18.04 is still going to be supported for a while. It's fine. We can keep using it for a while. But the switch to 20.04 will let us do things like getting rid of our current copy of Python 2 that ships in that snap, unfortunately. We need Python 2 right now because the Ceph version in 18.04 only supports Python 2. So we've got Python 2.7 bundled in there that makes it needlessly large. With the switch to core 20, because Python 3 is pre-included in the core 20 base snap, that means we don't need to start to ship Python inside of our own snap anymore. We might also be able to drop a few more things that we're currently building from source that we won't need to build from source anymore, because the version in Ubuntu 20.04 is going to be modern enough for us. So that should mostly appear to have, the only difference for our users really should be a drop in size more than anything else on that one. And now we enter Christian territory. So it's all of the low-level stuff. We have that list is pretty much all kernel stuff. We also have some amount of related work we do in NextC and NextCFS and NextD to actually make use of that, but that's mostly our kernel to-do list at this point. So I guess I'll let Christian go through that.
We can basically most of these things we discuss together, so we can also go through them together, I guess. I mean, one of the things that we've been working on for quite a long time, or that has been a topic for quite a long time, is VFS-based file system shifting that Stefan here listed first, which has a bunch of nice or desirable properties that we wanted for a long time. I start with a very obvious case, is often when you run, or how unprivileged containers work is that you create a user namespace, and user namespaces have a property called ID mappings. And an ID mapping basically means that while you're in the container and you appear to be UID 1000 or UID 0, if you look at the container from the outside, this process running with this UID will be mapped to something like 100,000 or 200,000. Now you can already see a problem. If you, for example, want to share a directory with your container or a file system mount with your container that has been mounted on the host, usually the files on such file systems or in such directories will be owned by a standard user like 0 or 1000, and it falls into the range of 0 to 5,000 or 60,000 or whatever, like a normal directory would look on the host. So when you mount this into the container and the container has one of those ID mappings set up, then you cannot write or interact with this file system that you're exposing to the container at all. So the container user can't actually write to the directory or the file system that you're exposed, because the UIDs and GIDs don't match up, and because the user namespace that the container is in does not have any privileges with respect to the host. So this is really a big problem. And most of our users want to share directories. You want to share your home directory, you want to share a data directory, downloads, whatever it is. For example, we are running on Chrome OS, and Chrome OS integrates your download folder from within your container on the host. And that that kind of gets tricky when you cannot actually write to the download directory. You need to come up with hacks, either with views or some other stuff that has potential performance impacts. It's also a problem because it means in order for a container to be able to write to its own rootfs before the container, or when the container is created, we need to recursively change the ownership of all of the files inside of the rootfs. And that can be a very expensive operation, especially when you consider that over time, a system container, like any other regular system or VM, will grow in size and in the number of files. And so if you're talking about a 10 gigabyte, 15 gigabyte root file system, and you need to change each file on this root file system, it's going to be very expensive for sure. And the idea is with this VFS-based file system shifting is that instead of having to chown, you tell the kernel what ID mapping you want, which basically means you tell the kernel what IDs you want the files to show up inside of the container. And we have tried different approaches over the years, and right now we're trying to implement a very flexible approach that allows you to basically bind mount any directory or file system anywhere into a location on the file system with a different ID map. So it means you could make your home directory, all files usually owned by UID 1000, you could bind mount it to another directory such as /mount and make it so that all the files within that home directory are not appearing as 1000 anymore, but for example, as 5000 or 1001. I'm not going to go deeply into the implementation details. Also, this is obviously interesting, but the really nice thing is that it allows you to do stuff such as making a USB stick appear in multiple locations and making it writable for different users, especially interesting for FAT formatted USB sticks and so on. Obviously, with this approach, you can also easily share file system between containers, although there are different solutions to that. But it is relevant when you have containers with different ID mappings, which is the use case that people still have, especially when they want to make sure that container processes from one container and from another container can't really interact with each other. So sharing file systems between containers, sharing file systems from the host with containers is a thing. And also, for example, for systemd, homed, which has the same concept or similar concepts where you take your home directory to another computer where your UID might be different from the one that you have on your home computer. With VFS-based file system shifting, or the feature, as I like to call it now, ID map mounts, this really becomes easy as you can expose it as whatever UID and GID that you like. It obviously has a bunch of security properties that make this safe. Another thing that we have been discussing, but the state of this is kind of right now is kind of in the, we're unsure whether or not this is actually going to happen, is isolated user namespaces. So the problem that we often have with these UID and GID mappings that I just mentioned with respect to user namespaces is that they have to have a certain range, right? You specify, I want to map all UIDs starting from UID 0 up to UID 10,000 to a UID starting from 100,000 to 110,000. So this is what we call a UID and GID mapping. And the width, so to speak, the 0 to 10,000, 10,000 is the range of this ID mapping. Now, obviously, when you're talking about a standard system, you have like usually at least 10,000, at least 100,000 IDs nowadays. Even higher up, if you think about programs such as LDAP and so on, they sometimes, when they drop privileges, set UID themselves to a user in a very, very high UID and GID range with the assumption that they won't interfere or won't be a fully unprivileged user that is not used by any other program at this time. But obviously with containers, this becomes a problem because most containers start with a range of 1 million or 100,000. So it actually breaks security properties. And the idea was to get around this by introducing something which is an isolated user namespace, which doesn't really make use of ID mappings in the same sense that normal user namespaces do. Instead, you extend the in-kernel UID from 32-bit to 64-bit, such that user space continues to be seeing the regular 32-bit UID space that goes from 0 to 4 billion something something or higher. I don't know exactly right now. But the kernel internally uses the upper 32-bit to assign a random UID to this user namespace, such that each user namespace that you create on the system has a unique UID and is therefore completely isolated from each other, from the other user namespace. We have been pushing for this concept mainly because one of the driving reasons for using non-overlapping ID mappings or completely isolating user namespaces is that unprivileged containers currently can exhaust each other's R limits, but there is a patch set up on the kernel mailing list, which is great, that would fix this specific issue. So one part of the motivation for having isolated user namespaces would be removed by this patch set, which is why we're not completely clear if this is still something that we might pursue, but there are still strong arguments why we would want something like this in Stefan.
Yeah, I think having the entire 32-bit UID GID space will still be very good to just fix a whole bunch of issues. And the other aspect being security in the face of kernel issues. Like, I still like the idea of having my containers not actually run under the same map, just so that if there is any way for them to escape the container, they will not be able to access the processes and file system of the other containers running on the system.
Yep.
It's obviously not great because they've already managed to escape to the host, so that's not amazing. But if they can do that without escalating to actual root, then there's still a layer of security from having them be isolated.
I think my main problem is that some of the stuff here, there is a difference between how we do kernel development and how we do LXD development, obviously, in the sense that we are in full control over what we do in LXD, LXC, and LXCFS, right? So if we decide that a certain feature is worth implementing, and we see that our users request this feature, then we decide that this feature is going to be implemented, we make a design, and then this is going to happen, and that's it. Anything that is on the list right here is basically a proposal that we are pitching to a project that is not in the same sense and under our control, and it has a way larger community. So pushing for something like this or requesting for something like this is requires a lot of coordination and effort. And so stuff like when we speak about isolated user namespaces, one thing that I always like to make sure, and that Stefan obviously also knows, is that this is with a big if. It's like, if people find this useful, and if there is a strong argument for it, then this is, and if the argument for it is strong enough, then this is something that we can potentially do. And
we're definitely doing. Yeah, that's also why we can do things in order. Like, I mean, we do the VFS part first because that makes sense. Regardless, we definitely want the R limit issue solved, so we're quite happy that Red Hat seems to be working on that, I think. Yep. So we're looking forward to that, and then once those 2 bits are sorted and people understand the current landscape in the kernel of what's possible, then we can try and pitch something like isolated user namespaces. Trying to do everything at once definitely confuses users to the point, users, contributors, whoever, to the point where we don't really achieve anything anymore. So we're trying to be kind of careful there.
Yeah. So for the rest is basically quick items, unless you wanted to say something.
Yeah, I can take the core scheduling one, I guess. Okay. So core scheduling, it's effectively a work that's been going on for a couple of year and a half, I guess now, or almost 2 years, to mitigate Spectre meltdown, hyperthread issues without losing the performance. So currently you've got the issue that if you give, if you ever end up scheduling at the same time one VM thread on the same core as another VM thread, there are attacks that would let one of the VM read the memory of the other VM. That's obviously a big issue in any type of shared environment. And the default kind of mitigation for that is just turn off SMT. So you just turn off multithreading entirely. Your fancy 96 thread CPU or whatever now turns into just a 48 core CPU, and you avoid that particular issue. But you also leave like 30 to 40% performance on the table by doing that. Core scheduling is a mechanism that will allow you to keep running with SMT enabled, effectively tagging your virtual machines, either each of them individually or like from a tenant point of view, for example, like all of those VMs belong to the same person, so whatever. And at that point, that will allow whatever is in that group to have processes be scheduled on the same core at the same time. So the scheduler grows that awareness and should be much more, will be able to use a lot more resources than with SMT just plain disabled.
But this is a this is a user space decision, right? I'm not sure if you...
Kind of. Yeah, so the actual interface is not set in stone yet. As last I heard, it's either something like PR kettle based or cgroup based, where you do need something in user space, and that's why it's kind of on our side too, needs to actually create those groups effectively. If it's C groups, it's pretty trivial for us to do. If it's PR kettle, we can also do it. It's not a huge deal, but we need to mark the processes that are affected by that and group them together. Like the most common case would be for like QEMU. When we spawn QEMU, we want all of the QEMU vCPU threads to all be part of the same group because it's the same VM. And then we let the scheduler do the right thing. So there's some amount of work there we need to look at. I think we will want to take a close look at what's going on the kernel side, because my understanding is that this hasn't landed yet.
No, we should. We should also, this is something I wanted to stress, we should also stress this is not work that we're doing, or in this case that I would be doing. So this is work pushed, I think, currently by Joel Fernandez from Google, who has taken this patch set over from a bunch of other people, Julian and Vinif, I think.
Yeah, there's still a few folks at DigitalOcean working on that. Some of the team members from that original team have actually changed employer since. That's why we're seeing Google work on it, because one of the person from DigitalOcean moved over to Google. But yes, it's still actively being worked on. I think the scheduling side is mostly working. Last I talked with them, they were still on bike shedding the actual user space interface for it.
Classic.
So once that's sorted, we can implement that. But I think at minimum, we want to take a close look to understand how that stuff's going to work. If we don't think they're going to work the way we want for both containers and virtual machines, then give some feedback so that when it is merged, it's something we can use. Because for virtual machines, the use is obvious, but I think we also care about doing that for containers. So having the entire set of processes of a container be considered to be part of a single group as far as scheduling, for the same reason, so that we don't end up with a potentially privileged process in two different containers being able to access memory in one way or another. So yeah, that's stuff going on. You want to take the last two items quickly?
Yep. Just quickly go over the last two items. One thing we've been considering is a per pit namespace max pit value, so that containers can reduce their max pit value, because this is currently not possible. If you set a max pit value, it applies to all containers equal. It applies to all. It applies system-wide basically. And this is an issue in, for example, environments where you run Android in a container, or other libraries that make assumptions about what the maximum pit value is supposed to be. There needs to be some flexibility here, we think, and we have a bunch of use cases where this is relevant. So we would basically be namespacing this, or making it hierarchical. Hierarchical probably doesn't make sense, namespacing this, I guess. Or maybe if people don't want to namespace max pit, introduce a new sysctl. We need to think about this, how this exactly is going to look. And last but not least, one thing we've been thinking about for a while, and I haven't made my mind completely up whether or not this is usable or easily doable is cgroup and PIDFD integration, so that, for example, you can specify to kill all of the processes inside of a cgroup based on a PIDFD. Is this something that's also been requested by systemd? Maybe there's a better way of doing this, killing all processes in a cgroup. Basically, we don't want to iterate through all the processes in a cgroup and kill them. We want to kill all of the processes that are in a cgroup by just sending, for example, a single signal. And that can be implemented in various ways. PIDFDs and cgroups is one nice integration point, but maybe we can make this work with a different implementation as well. We'll see.
Something I just thought of there, like, do we already have an interface that lets you add the process from a given PIDFD to a cgroup, or do you need to pull the PID and then write the PID?
You probably would need to pull a PID, but I don't see any issues with either adding an ioctl. Actually, I'm not. I never said that. I don't like ioctls, especially.
I was gonna say, like, only problem with adding an ioctl. Well, it's an ioctl, but
yeah, exactly. I mean, there are ways you can do this nicely, and the main problem is always that you want to do it in a race-free manner. And obviously, this is kind of the same issue that you have with sending signals, where if you pull the cgroup from the PIDFD and then you make a decision based on that information, in the meantime, somebody could have already moved you into a different cgroup. So either you would need some sort of poll interface probably, or something
like the other way around, but they're kind of the same thing. Where, like, I've got a PIDFD, I don't really know what the PID of that PIDFD is. I'm not even sure if the thing is still alive or whatever. I just want to make sure it's in that cgroup. So I would like to, instead of putting the PID and writing it, then just pass the PIDFD effectively. And then if that PIDFD is no longer running at the time, we just get a clean error. We don't risk racing.
Indeed. But that's it so far, I think.
Yeah, and then kind of the rest, which is like all the stuff that's not technically on our roadmap. We've got a number of issues open on GitHub for a variety of smaller features that are not really roadmap worthy. Those issues we will often actively mentor anyone who wants to work on those. So we've been participating in Hacktoberfest. We're participating in some programs with some universities to get their students to contribute to LXD. Or anyone else, like anyone who's watching this who wants to contribute to LXD, like, please go look at our list of easy issues, either looking on GitHub for that label or on the forum, where we've got a post that's always up to date with the list. We also always keep an eye on what's going on both on the discussion forum and on GitHub, not only for bugs that we need to fix, but also for small tweaks and improvements we can do very cheaply in just a few minutes that would make someone's life quite a bit easier. So we're actively looking for those, and we will often do a whole bunch of that. We're also hiring. So we're currently looking for someone with C and distributed systems experience to work on dqlite. So effectively doing dqlite, libraft, libdqlite, go dqlite, libraft, and libdqlite. This is a remote work position. We are looking for folks in Europe or the Americas. That's mostly from a time zone reason for us, like anywhere further east, and I don't really have any overlap with you. And if we go way more west, then there's no overlap with the Europeans. So we're still a pretty small team, and we're trying to keep things currently in Europe or Americas. You can get all the details at the link here. And if you think you'd be interested, then apply and we'll get in touch. And that's it for all we have. We're just a few minutes over time. I have not seen any question in the chat, despite asking folks if they've got any. So we're gonna go with nobody has anything. Feel free to leave comments once the video is no longer a stream, but it's actually a YouTube video. You can ask questions there. We'll answer that. Otherwise, you can go on our website for more details. You can go and look, try LXD online at that link. There's also, you can go on our forum and ask more questions there if you want. And that's it. Hopefully this was useful. It was a good way to get some visibility on what we're up to, and also you get to see the entire LXD team. So thank you for that, and
Thanks for watching.
Yeah, we'll have one of those in another 6 months probably, and we'll do more other normal streams from until then. All right.
Bye.
See you.
Thanks.
Bye bye.
Yeah.
Bye.